Before I start, going through the presentation, I think what's important is we talk about data, right? We are in 2025. We are in a time where data is everything. Unless and until we know precisely what are we solving for, um, looking at a solution to solve for it is stupidity, to be honest, right? So it's extremely important to genuinely look at data as much as you can at a granular level and then figure out what to do. And because today's topic is of very, very high interest to me, in fact, I've spent last 8 years of my life on precisely this HVAC efficiency and air quality. So this is the conclusion of me being here for the last 8 years, managing air quality in around 26 million square feet in India and UAE. This is what I feel, that there are a couple of data points that we should generate, and then look at how can we use that data to solve for the problems that we're talking about. So the first problem that is pretty obvious when we're talking about air quality is that let's install air quality monitors. Could be under the well building guidelines, could be under IGBC, or any other guidelines, right? And just measure air quality properly. This is precisely what the last speaker spoke very well on as well. And Mr. Kapoor was highlighting how it's important to monitor air quality, and I completely agree. But there are a couple of other things also which I believe we should monitor, apart from PM 2.5, CO2, PM10, NOx, SOx, etc. We're ultimately talking about thermal comfort of occupants. Of course, this does not go for a lot of different kind of use cases like data centers, etc. But then when we're talking about thermal comfort for occupants, like an office space or a mall or a large government building for that matter, or even a hospital, these sensors would make more sense. It's important to understand where you have higher number of people, where you have lower number of people. Hence, density of people is extremely important. And this is precisely what my sensors here do. Sensi count and sensi point are occupancy sensors. The first sensor is a people count sensor. It is installed on the entrance exit of gates. It can be installed at the entrance or at the doors of large meeting rooms or training halls, right? Or boardrooms for that matter. This counts in real time how many people have entered or exited that particular space. Helps you understand and calculate on the tonnage that might be required, because all our bodies are emitting some amount of heat, right? So it helps understand and calculate in real time what kind of BTU consumption will happen as X or Y number of people have entered this particular space. And we should keep the VAV open larger, or the AHU should do X, Y, and Z. Similarly, the thermal occupancy sensors, these are also ceiling mounted sensors. These are there in the occupied areas where people sit and work. This helps you understand exactly how long and from what time to what time people are usually sitting there. And this helps us understand precisely on the low side, what can we do, what optimizations can we bring in. So let's look at a diagram here, okay? Simple 2D expression of any regular office. So if you see here, you have around 10 people here, and this space might be good enough for, say, 30, 40 people. Of course, this can be used for a very large space as well. We're using this for airports now. Clairco is deploying all of these things at a couple of airports here in India. So you can imagine the scale can be very large for a similar solution where you understand occupancy and start controlling utilities according to that. While marrying your air quality data. Air quality data continues to be the base of this, extremely important. But then, of course, you also have to look at thermal comfort. It's common sense, right? If it's a 10 packs meeting room, if there are 10 people, the odds are that the carbon dioxide level will increase. The odds are that the room will become warmer. So at that time, based on occupancy, we can keep the VAV open at probably at 100%. And probably the AHU, which is connected to that, can also run at a higher VFD setting or a lower set temperature. This is precisely what Clairco systems are doing. My sensors are ceiling mounted sensors. They understand how many people are there using the thermal imagery of our bodies. So all our bodies are emitting some amount of heat. Our hands, our faces are emitting some amount of heat. My sensors are basically thermal sensors, which can precisely count that this room has 8 people out of a 12 people seating. There are 8 people right now, or I can understand there are 5 people there, or in a larger office, which might have space for 2,000 seats, there are only 1,200 seats which are occupied. Based on that, we are able to understand a couple of things. Of course, consistently, I'll keep on repeating myself, marrying that data with IAQ data like carbon dioxide and PM 2.5 and other data are extremely important. So our IoT systems are talking to HVAC as well. What's extremely important is, and this is where I believe the current BMS systems are missing the point. They might be integrated BMSs, but they're not truly singular. What I mean by that is that these systems are feeding information only for their own, and they're giving the data on a single platform, but they're still working in silos. What I'm saying is, why can a lighting management system data not also work for VAVs? Why can a CO2 data also work for understanding occupancy, right? In absence of a couple of sensors like I told you about. Hence, marrying both all of these data are extremely important. So in fact, that is where the direction of all BMSs should be going, towards a singular system which is using multiple sensors and gaining intelligence out of this instead of just using that information for that particular system. For example, if a filter is clogged, is that automatically sending information to the vendor that please send quote or send the next shipment of filter, which is not happening. As and when every system, if you look at it, everything is ultimately based on the BMS operator's shoulders, which is so unfortunate. Because if you think of what's happening in India, usually the BMS operator is not a very highly skilled guy. And unfortunately, what's happening is they're not taking corrective actions as required. We have some consultants on the call, and buildings are designed really, really well. They all get the certifications that you want. But over the years, they're not managed as well. Why is that happening? Because there is a lot of manual intervention required. Hence, at Clairco, we were very clear that Clairco should have zero manual intervention forever. And that's why we have a lot of AI, for which we've also received a couple of global patents, which I'm going to talk about. First is the occupancy detection bit that I told you about. Second is, after we understand the occupancy-based heat load, we look at what is the ambient heat load. How sunny is it? If it's going to rain, or what are the ambient conditions that help me decide in real time what is the tonnage of cooling which is required for that particular floor. And based on the readings and understanding of how much BTU or how much tonnage is required, I am able to control the low side of HVAC of chillers, of a large commercial building, to help you save energy. Just to give you an idea, what we're doing is we're looking at multiple sensors which are interacting with the gateway sends the data to the cloud, or we can also, of course, do it on-prem as well. And this controls your different thermostats in real time. This can be your VAV's DDC panels, this can be your AHU's thermostat, or could just be controlling via the BMS, right? All these four things are possible. And we can, of course, integrate using BACnet, RS485, LoRa, all these things that we think about, and now PoE as well. We're doing a lot of PoE-based projects as we scale. So if you look at the energy savings that we've been able to bring in, please look at the last column. There were some buildings which were fairly energy efficient. And despite that, Clairco has been able to bring in substantially better energy saving. As one of the speakers was pointing out, if a building needs 175 tons of cooling, it doesn't need that sort of cooling throughout the year. That's why you need a variable sort of a system which understands occupancy and then also looks at and controls the system to save energy. This is precisely what Clairco does. Understands where you have higher number of people, where you have lower number of people. Understand carbon dioxide data, understand IAQ data. Based on that, we are bringing in intelligence to ensure all of these things are being achieved. In fact, if you look at our air filtration that we talk about, and Mr. Nair will be very happy to see this because the last time I spoke to him was a couple of years back. And the filters that we've built are also V-band filters, working on the similar principles that his company is leading in and doing a great job. And we also have the V-band filters, which are very energy efficient. So we have non-electric filters, which also provide for great energy saving because of low initial pressure drop, which controls the air quality. Then we have different kind of monitoring with AI, which is controlling the HVAC from an energy efficient perspective, and also from a balancing the air quality at the same time. During COVID, we also launched NanoClair. We have a global patent on this. This is also a TiO2 based metal mesh, which has a silver nanoparticles based nanochemical on it. This can break down anything which is organic in the air, something like a COVID-19 or a different virus or a bacteria, including your formaldehydes and toluene, different organic gases of the world, benzene, etc. So this is not only helping us reduce live organic matter, but also other non-live organic matter, right? So this can completely replace your activated carbon filter, which might have a very high level of static pressure. And this has static pressure of roughly like 5 or 6 pascals, which is almost negligible compared to activated carbon filters. So the lower static pressure also brings in substantial energy saving. In fact, we always guarantee ROI on our filters to our clients. The ROI could vary between 3 to 18 months, depending on what kind of sensors and air filters we're talking about. So this is what we've been doing. And of course, it's important to also keep on telling people about air quality and the sustainability efforts that the company is doing. So we can provide all of that in a way where anyone who's entering the building can understand that data better as well. So this is what we're doing using multiple data points from air quality to occupancy and controlling the HVAC and reducing pollutants to filtration altogether to provide for a better air quality while balancing for energy saving in large commercial buildings.